Okay, so good morning, everybody. Sorry about that. For those of you who came from Instagram, yeah, I've been trying to print this to finish this print I started out this morning. It's actually a new material. We'll talk about that in a second. But welcome to episode 3 of MakerBot Chats. My name is Felipe. I'm an industrial designer and also creative director here at MakerBot. And here at MakerBot right now means here in my living room. So welcome live from New York City, uh, downtown New York City, I suppose. Well, actually Upper West, but live from my living room. As you know, we've been doing kind of these short episodes of just kind of a Q&A session with you guys, having different subjects, whether that be on the first one, what was the effort that MakerBot was putting on in creating face masks to support the COVID-19 local response. Now, episode 2 was about labs and materials, the different options that you have with the method system. And right now, episode 3, it's about choosing the right 3D printer, right? So, uh, in the past couple of weeks, a lot of my friends, my design friends, have come up to me and asked me, like, well, I want to get a printer, now that I'm at home. Probably I used to have one in the studio, but now I want one for my home setup. Which one would I choose and why? Even within MakerBot, we have quite a few different options for you to choose from. But I'll do two things today. So I will cover kind of a high level view of the different systems, kind of the big three systems available for you to choose from, those being SLA, FDM, and SLS. That's kind of the big broad categories that I usually use to describe 3D printing. And then I'll also touch on the specific printers that are available in MakerBot and what are the difference. I have quite um, a few prints that I've collected through the years. Some of them are from older systems, so I want to show what are the differences between them. Why would you choose one versus the other? What are the implications also, right? What's better from a replicator to the original one to a resin printer or a method printer, right? Why would you choose one or the other? And as usual, Alejandra is behind the scenes somewhere in the internet, somewhere else where we're not together, but she's actually collecting all of the questions from you guys. If you have questions, don't hesitate to shoot them out in the comment section right on that YouTube box. Or also, right now we actually developed, thanks, big shout out to Alison Munson. She developed a quick sign up sheet where you can actually sign up to hear more about these episodes, maybe newsletters and upcoming announcements. So if you go to makerbot.com/chats, you can sign up and get that information as well. Or just send me an email, felipe@makerbot.com. But with that, that's kind of a quick intro. I'll get started. And, as I was saying before, I think, personally, right, it's more of my personal opinion, but I think that there's three big systems out there. You can get a lot more granular than this, of course, but this is where I would start a conversation, right? Overall, you have SLS, which are powder-based systems, SLA, and FDM. So SLS systems are going to be most likely large format. They are also, I would also throw in there the polyjet systems. They tend to be a little bit more complex. More often than not, they are pretty big machines. Not only are they more expensive, but they are also, well, they require a bigger area to be deployed at. And they can be complex, but they can print with very specific materials, kind of ceramics, sometimes metals. We've seen that also. But I would say it's a very niche, very specific application overall, better suited for heavy industries, right? Not so much, I would say, maybe not so much for everyday use or everyday prototyping. Then SLS printer or resin printers, what I have right there, right? Those are great for specific applications like jewelry, like dental applications, because of the way that the system works, the actual resolution that you have. And that's not to say that you cannot achieve that resolution with some of the FDM printers or the filament-based printers. It's just the precision is a little bit different because in both SLS and SLA, you're using a laser to cure the material, right? So instead of the nozzle, so I have right here one of the method extruder, right? The method actually liquefies the plastic as it goes through, and that's true for all of the MakerBot extruders. It liquefies the plastic and then it deposits it in place, right, where you're building the part. With an SLS, as an SLA system, there's a laser pointer basically that's drawing that shape. It draws specifically in the resin-based printers. It will draw it against a resin and it will slowly cure it, right? So that allows you to have very intricate parts, but it's hard, if not, I would say impossible, to print with multiple materials because you can only have one type of resin. And what that means is that you cannot have soluble supports, you cannot have anything other than breakaway supports. And I'll talk about that in a second. What are breakaway supports? And I have actually a sample of a resin print. What are the challenges with that? Having said that, as I was mentioning, I think, let me start actually, I skipped one of the comparison. There we go. I would focus on the two systems that I was talking about at the end, right? So SLA versus FDM, and FDM represented right here by the method on the right. But starting with SLS, why would you choose SLA, sorry, or a resin-based printer? And what are kind of the not great features about it? Specifically, uh, it can be hard, right? So far, I've owned 5 machines, I would say. So I had a form printer at some point. I've had a Rep 2, which was my very first printer. Then I also had a Rep Plus. Now I got a Method, which is awesome. I'm super excited, but I probably mentioned that a lot in the last chats. Um, and overall, my experience with resin is that it can get really great results, right? I'll have a picture of this part. So this is a part that I printed a while ago. It's a little bit dated, but the resolution itself, the transparency, the layer quality, it's pretty nice. It's kind of awesome. The material, it's really interesting. However, managing the resin can be really cumbersome, especially like in a tighter setting. If you have a small studio, if you have not an industrial setup, even here, right, in my apartment, it would be really hard to manage a resin because you have to wear gloves. It's kind of hard to cure the resin. Um, it's a great system for certain specific applications, like for jewelry, for these very intricate parts. It's definitely super useful, but it can be definitely a hassle to maintain and to use. And on the other hand, when we talk about FDM and specifically in this case method, you have things that are really, really, really focused on making it easy for you to run the system as a whole, right? It's not only the printing process, but the maintenance. So the actual printed parts, the fact that you have soluble supports, right? How do you get rid of these supports? So in this, again, going back to that SLA part, these are what we call breakaway supports. I'm sure that some of you guys have seen these supports being generated by programs like Mesh Mixer. Also, the Formlabs dedicated slicer will generate these tree-like structures that are basically trying to create supports and tapering them in. Let me get that closer. Tapering them in to a thin little rod as close as possible, as small as possible as you get closer and closer to the part. That means that some parts that are intricate or have internal cavities will be really hard to clean up, right? Unlike what happens with a dual material printer where you can actually just dunk the part in water, dissolve the supports, and get it over with. Um, yeah, and one of the challenges, which is one of the great advantages of SLA, would be that with an FDM system, it's hard to create like very intricate parts, like more what I was describing, like jewelry applications, dental applications. It probably is not ideal because, as I was saying, you're having a little bit of a thicker market, right? Think about it that way. You're either drawing with a little, very thin nozzle, in this case the laser of an SLS, versus the nozzle, the thicker, a little bit thicker nozzle of an FDM. But I think that overall, and I'll talk about the printers themselves as well. But overall, it's easier to grasp the story behind them by focusing on the parts. So I have quite a collection of parts now. Luckily so, because I cannot go to the others and print some more examples. But I have a few printed parts that I've collected through the years that were done in different types of printers, right? So in this case, the part that I've been showing so far, it's an SLA printer. It's a resin print. And as you can see in the photo, and it's the part that I'm holding right here, it's a really clean part, right? It's very complex. It has this little, let me get that closer, has this very little, very brittle elements here. This part was actually, it was meant to be a sculpture. It was an abstract representation of time passing by, but anyways, an old project in a previous company that I worked for. But as you can see, the elements that I was talking about before become very evident here, such as you cannot use all supports other than breakaway. So the printer will create these little tree structures to support the part. Um, and you're a little bit limited in the print size, right? Of course, there are now bigger printers that can print larger elements with resin, but it's still going to be, it's a tricky process. I've done it in the past, and it's interesting for some applications, not so much, I wouldn't say, for some of the prototyping stuff that I've done, because it implies also having more steps in the process, right? So you might be getting quite a nice finish, quite nice details for very, very intricate cavities, but you get challenged in the supports, you get challenged in the process. I have, moving on, and be sure to ask. I see some of the questions are already coming in. I'll answer them as I go through. Let's stop, in this one. Also, somebody who owns a replicator 2X and the nozzle head broke. Okay, I'll touch on the very specific questions in a second, and then let me come back to that one. Let's see. The nozzle broke and some of the plastic components were prone to cracking. How has Method improved in terms of durability and cost of repairing? Well, the printer itself, so the Replicator 2X, if you have, for all of you guys who are familiar with the older generation of MakerBot printers, the extruder was itself very basic, right? It was basically a heated element that would allow the filament to run through and then push it out. The newer version of the MakerBot extruder. So this I would say. Let me come back first to the webcam. Oh, sorry. Here we go. So this would be generation 2, I would call it, of MakerBot extruders. What this person is describing in the question is in the Replicator 2, that's a previous generation. And then the new generation in Method, it's even, I would say a little bit more complex and a lot more efficient at what it does. So these new extruders are able to actually track filament jams, are able to have a longer heating distance, right? So that the material is, let's call it, happier as it extrudes. It takes a slower, say, a longer melting process for the plastic to come out of the nozzle, which in turn makes the process itself very, stable as a whole. So that would be the answer, right? Many of the newer extruders, specifically on Method, you don't see this in many desktop systems. Many desktop systems, I've seen that, the nozzles are, not the nozzles, but the extruders are kind of this big. They don't have a lot of smarts on them, to be honest. And it's basically just a heating element that pushes filament through. And it doesn't even have the motors integrated to them. So with the newer extruders, like this one, you can actually see here, there's a whole gear set integrated into an extruder that actually helps you push material at a more even rate and a more controlled rate than traditional desktop systems. Coming back to other examples of printed files, right? So a lot of people, and actually a lot of my friends, came to me asking, like, well, why wouldn't I get just a basic Rep Plus printer? And the Rep Plus printer, it's an amazing machine, right? We've had it for probably over 4 or 5 years now. I had it before. I still have it, but it's actually in storage right now because I'm focused on the Method printer. It's an awesome machine, but it's a single extruder machine, which also means that you can only print material in support in the same material that you're printing the part at, or choose not to have supports, which is what happened on this part. So this part I printed on a Rep 2 actually. The Rep 2 was the first MakerBot printer that I had. And I wanted, it's a fairly intricate part, which is why I didn't want to use supports, and I wanted to create something that was self-supported. So I had to accept that at some point, you can see it here, and you can probably also see it on the photo. Where is it? Here, right? Some of these unsupported areas would be having these overhangs that prevented the filament from attaching properly because I didn't have supports, right? And the reason why I didn't want to have supports was in this sort of hollow structure, removing those supports can be really hard. It's kind of super tricky. And ultimately, this is actually a coin bank, right? So I didn't care much about that one face. It's a icosahedron, so I just made it so that it was mostly unsupported. It was just that little area that would have required supports, but I didn't want to challenge or to deform the whole part, just by that small section. So with more basic systems that only have a single extruder, you have to think about that compromise, right? Either using no supports or using supports that are going to be breakaway, and because of that, in some shapes, can be really hard to remove, right? It can be really tricky to remove the supports that come inside of that hollow structure. So imagine, all of those tree-like branches inside of this part and me trying to ply them out, it's just going to be really hard. When you have a dual material system like Method, when you're able to print with soluble supports, that basically means, and I have one such part, let me bring that here. So when you have a dual a dual material printer, that basically means that you don't have to think about it anymore, right? You're able to just print the part, in this case this gear, and dissolve the supports. It's as straightforward as it sounds. So this is an actual part that I printed yesterday. It's using, it's kind of a new material. I cannot talk about it yet. I'll mention about it in a second. But it's using SR30 support. So this white element is a support structure. This part is hollow. It's kind of a door handle for a car, right? So the part itself is hollow inside, and because of that, it requires support material to hold that part up. These supports, I just need to dunk them in water with the solution for SR30 and they go away, right? So I don't even have to think about me applying those supports out. I can print much more complex parts because I have the ability of using those two materials. One material for support, one material for the actual part. And that's the big jump, I would say, that has been made with the method systems versus the replicator systems. Overall, right now, we have three systems, three main systems of MakerBot. I'm skipping the Z18. You guys might have heard of it. That's our large format printer. I don't have it here because it's a very specific application. So if you want to print large objects, go check out the Z18. It's a great machine. But anyways, I would say the three main systems that we currently support in MakerBot are the Rep Plus, which is great, has been used a lot, especially in education. Kind of a workhorse, single material though, right? You can only use one material for both the part and the supports. The sketch printer, which is our newest addition to the education platform, and the Method. So both the Rep Plus and the Sketch are great printers to start with. Like if you're just trying to understand how the printer works, if you're just using it for school applications, for printing in the classroom, specifically now that kids are kind of studying from home, it's a great system because it's super simple, super straightforward. The filament is just a spool of filament, you load it in and you're ready to go. But if you're trying to create a little bit more complex parts, if you're an industrial designer like myself, a mechanical engineer that requires the parts to have a certain strength, right? If you want to print with specific thermoplastics like ABS, which is what Legos are made of, ASA, or nylon, etc., you will be way better off with a Method because it can print much more complex parts and it actually supports a way wider range of materials. And right now there's an amazing promo. I know that I've said it in the past, but the price difference between the Rep Plus and the Method, it's not that steep anymore. So I would encourage you guys. I'll talk about the promo in a second, but as people ask me like, okay, which printer should I use? If you're a professional right now, getting a Method, it's a no-brainer because you have so many materials that are super easy to use, that come with, they don't come with a machine, you just buy them with the machine. The machine enables you to do so much more and so much more complex parts than just keeping it basic with a single extruder system. And I'll start touching on some of the questions. How much does it cost to replace the nozzles if they break or jam? Okay, so it depends on the system. Actually, I have the extruders here. I don't, this is the experimental extruder that we launched for the Replicator Plus series. This guy, if I'm not mistaken, is $250. However, it's not, I've never had the extruder break, and if it jams, it's still possible to open it up and get the material out. But the thing with these extruders is that they are harder to jam because they have embedded sensors in them, right? So they will detect the jam before it happens and sort of reverse the material out, so reverse this little extra tip of material, and make sure that they stop themselves before they create a more difficult clog to clean. So it's usually a matter of just purging the material, so pushing it back out, actually pulling it back out, and that's about it. So this guy is 250. The method extruders, I think that they are about the same price. I would have to double check. No, 299 maybe. I would have to double check the price on it. I've never had a method extruder break so far, and it's partly because they are so different in how they are built. So this is a replicator extruder. These up here, these on the right, my right, your right, yeah, is a method extruder. The method extruder is way longer and it has much more sensors in it. Not only that, but it also has what I was saying before. If I look it on the back, so the regular replicator extruder has only this wheel that actually attaches to the stepper motor in the carriage to push the filament through. With the method extruder, you actually get a full gear box inside of the extruder, and it's quite literally a gearbox that actually attaches to the encoder, to the stepper motors in the carriage, and amplifies the force that the carriage has to push the material through. I think it's like a 1 to 20 or 1 to 40 ratio, like just based on that gearbox. That actually means that it's able to push materials so much harder and so much more precisely. Not only that, but it has more advanced sensors that detect whether the filament is flowing at a constant rate or not, whether it's actually being liquefied enough or not. And touching back on that promo thing that I was saying, so right now with that 30% off, the method printer starts at around $3,500. I think that the replicator plus is $2,500. So overall, like, why would you choose, taking it back to the beginning, why would you choose a resin printer versus an FDM printer, or an FDM printer versus a resin printer? If you're printing something very intricate, if you're printing something like, jewelry, like, very nuanced objects, probably you could use a resin printer. The thing to keep in mind, though, is that the resin process itself can be really tricky, right? It's hard to manage. It's keeping the resin in place. It's not as easy as just keeping, a spool of filament around, which is kind of static, right? And even the printing process is also not straightforward, because in this case, once the print is done, I just take the part out of the machine and wash it, and that's it. With the resin printer, first you have to wash it to remove the excess resin, then you have to cure it, and then you have to, I think that's it, and then you just clean it up. But still, in my experience, that's better suited for other applications, more specific ones. I really like FDM better. It's just a straightforward process. And within FDM, why would you choose a method versus a Replus versus a sketch? So method is just the freedom of material choices. It's amazing. And at this price point, it's just, for me, it would be a no-brainer, right? It's like you're talking about 2,500 for the plus and 35 for the method, or about that price. I would go check that price on makerbot.com/method. But with that price point, what you end up getting, it's a beast of a machine. So you have like so many extruders. Now with the Labs extruder, adding more materials is easier than ever. So you have quite a range of options with the method that you don't have with the regular FDM machine. And not only the material options, but also the actual sturdiness of a platform, right? So being able to print with the peace of mind that your parts are just coming out. So it's a tinker-free material, what we usually say. Let me go back here to the webcam. A tinker-free system that basically allows you to focus on doing stuff, not so much on fidgeting with the printer and fixing the printer and trying to make it work for you. So yeah, I think overall it all depends on your application. So the things that I would keep in mind is, what are the materials that you're looking for? What types of parts are you trying to print? Are you printing something very small, something very delicate, kind of intricate? Or are you printing prototypes? Are you printing fix and fixtures? Are you printing, more large-scale format parts like these guys, right? And even if you're printing like large parts, then it comes down to, okay, do you have very complex structures that require support that you would rather just dilute instead of having to ply out? Or are you really printing a single material, right? With something like the Rep Plus. So those are the big questions to keep in mind. And touching back on the materials, I do have a piece of news for you before I start closing up and wrapping up and looking more at the questions that we have coming in. We're actually one of the parts that I was printing right now. It's a new material, which I will be talking about next week. It's a pretty exciting one. I cannot talk say much about it right now. This part is made of the new material, so it's black. It's actually pretty strong. We're able to print it on the Method X right now. It uses SR30. Oh, I missed that, but that should say uses SR30 for support. And it's a pretty sturdy material. So we are adding new materials to that list, and that goes back to that initial statement of saying like, okay, with Method, you're not only buying the machine, but you're buying the whole platform. As we add more materials, as we add new extruders that allow you to use more materials, then basically your printer keeps getting better and better without getting a new one, right? That's what I love about it, right? Right now, I have 5 different extruders, right, between the labs extruder, extruder 1, extruder 2, 1x, 2x, that are able to print. I think right now it's about 11 different MakerBot dedicated materials, plus the labs materials that are open. Basically you're able to side load any material that you want without having to think much about it, and still benefit from the heated chamber, benefit from the dual materials. So it's a really sturdy platform. But overall, I would say go check it out. And as we start wrapping up, I would say if you have any more questions, let us know. If you have specific ideas of other topics that you would want us to cover in future episodes here of MakerBot Chats, also send us coming back to the webcam. Send us your comments, and make sure to connect with us either on makerbot.com/chats, where you can join our newsletter and let the first to know on what are the future episodes. Send us some questions. Also, hello at MakerBot or Felipe at makerbot.com. It's a great way to reach us. The comment section in the YouTube channel, it's also great. And for now, that's it. Let us know what you think, if you have ideas for other episodes, and we'll talk to you guys next Wednesday. Oh, and by the way, tomorrow there's a webinar on supply chains. So our Pro Segment Manager, Sean Miley, and Mike Mignari are doing a specific webinar on how has the supply chain changed because of this current situation, right? What are the implications? It's a great one. If you're interested, make sure to jump in on that one, but that'll be tomorrow. And if not, I'll see you guys next Wednesday. And for now, that's it. So I'll see you next Wednesday. Have a good week and enjoy the rest of the week. Thank you.